Welcome back to Everyday Nuggets. Rocket engines represent the pinnacle of human engineering achievement. These remarkable machines generate enormous thrust by controlling explosions powerful enough to lift massive structures off Earth and into orbit. At the forefront of modern rocket engine development stands SpaceX, revolutionizing space travel with its innovative Merlin and Raptor engines. But have you ever wondered exactly how these marvels of engineering are created? The process is far more complex and fascinating than most people realize. Today, we're taking an unprecedented journey into the heart of SpaceX's manufacturing processes to understand how they build some of the most powerful and efficient rocket engines in human history. From raw materials to final assembly, we'll examine the cutting-edge techniques that have enabled SpaceX to significantly reduce costs while enhancing performance. Before we dive into the manufacturing process, it's essential to understand SpaceX's engine lineup. The company has developed two main engines, the Merlin and the Raptor. The Merlin engine powers the Falcon 9 and Falcon Heavy rockets. It uses RP-1, a refined kerosene, and liquid oxygen as propellants. With approximately 190,000 pounds of thrust at sea level, the Merlin has one of the highest thrust-to-weight ratios of any rocket engine ever built. This efficiency comes from its gas generator cycle design, where a fuel-rich preburner powers the turbopump turbines. The engine also employs regenerative cooling, with fuel flowing around the nozzle and combustion chamber before ignition to prevent overheating. The newer Raptor engine, designed for the Starship and Super Heavy vehicles, represents a significant technological leap forward. It utilizes liquid methane and liquid oxygen in a full-flow staged combustion cycle, a more complex but efficient design. The Raptor engine family has evolved rapidly, with Raptor 2 currently generating approximately 230 metric tons, 507,000 pounds, of thrust. The upcoming Raptor 3 is expected to produce around 280 metric tons, 617,000 pounds, of thrust, making it one of the most powerful rocket engines ever developed. But how exactly are these engineering marvels manufactured? The journey of a SpaceX rocket engine begins with the careful selection of materials. Rocket engines must withstand extreme temperatures and pressures, requiring specialized materials that can handle these demanding conditions. For the combustion chamber and nozzle, SpaceX uses high-grade copper alloys, particularly a copper-chromium-zirconium blend. This material exhibits excellent thermal conductivity, enabling it to effectively transfer heat away from critical components. The turbopumps, which must operate at incredible speeds to deliver propellant to the combustion chamber, are crafted from high-strength nickel alloys capable of withstanding both extreme temperatures and the corrosive effects of liquid oxygen. SpaceX has worked diligently to establish reliable supply chains for these specialized materials, while also vertically integrating much of its production. By bringing critical processes in-house, they've gained greater control over quality and significantly reduced costs, a key factor in their ability to disrupt the launch industry. SpaceX's manufacturing approach diverges significantly from traditional aerospace methods. Rather than relying solely on conventional casting and machining, they've embraced cutting-edge techniques, including 3D printing, also known as additive manufacturing, has revolutionized how SpaceX produces complex engine components. The Super Draco thrusters for the Dragon spacecraft were among the first fully 3D printed rocket engine components used in flight. For the Merlin and Raptor engines, SpaceX uses direct metal laser sintering to create intricate parts that would be impossible to manufacture with traditional methods. While additive manufacturing is key to making these intricate geometries, conventional manufacturing methods, such as forging and machining, continue to play crucial roles in producing other engine components. This approach not only reduces the number of components required, but also allows for geometries that optimize performance. Another key innovation is SpaceX's use of friction stir welding. This solid-state joining process creates stronger, more reliable bonds than traditional welding. This technique has been crucial for fabricating the regeneratively cooled nozzles, where structural integrity under extreme conditions is paramount. These advanced manufacturing techniques have allowed SpaceX to reduce production time from years to months, dramatically accelerating its development cycle compared to traditional aerospace companies. This speed has been a critical factor in SpaceX's ability to rapidly iterate and improve its designs. As Raptor components are fabricated, they move to SpaceX's sophisticated assembly line. Unlike traditional aerospace manufacturing, which relies heavily on outsourcing, SpaceX brings almost everything in-house, giving it unprecedented control over quality, timelines, and costs. Assembly begins with the careful integration of the preburner, main combustion chamber, and turbopumps. Technicians work in cleanroom environments to prevent any contamination that could be catastrophic during engine operation. Each connection must be perfect. There's zero tolerance for error when dealing with components that will handle extreme pressures and temperatures. What makes the SpaceX assembly process truly remarkable is its use of automation. Custom-built robots handle precise welding operations that would be nearly impossible for humans to perform consistently and reliably. These robots work alongside highly skilled technicians in a carefully choreographed process that balances machine precision with human oversight. Is testing a rocket engine actually more complex than building one? SpaceX's testing philosophy can be summed up in one word: relentless. Every Raptor engine undergoes a series of increasingly demanding tests at SpaceX's facilities in McGregor, Texas. This multi-stage testing approach includes: first, individual components undergo rigorous testing before they are assembled. The turbopumps, for instance, are tested separately to ensure they can handle the extreme rotational speeds and pressures they'll experience in flight. Once assembled, each engine undergoes cold flow testing, where propellants are run through the system without ignition to verify proper flow dynamics and check for leaks. Next comes the crucial hot fire testing. The engine is secured to massive test stands designed to withstand the incredible forces generated during operation. Engineers monitor thousands of data points in real time, measuring everything from combustion stability to vibration patterns. What's fascinating is how SpaceX intentionally pushes these engines beyond their operational limits. They don't just want to know if an engine works. They want to know precisely how and when it will fail. This test-to-failure approach has been revolutionary in the aerospace industry. The most distinctive aspect of SpaceX's engine development is its rapid iteration cycle. Unlike traditional aerospace companies, which might spend years perfecting a design before production, SpaceX adopts a philosophy of continuous improvement. The first Raptor engines were significantly different from those flying today. With each test and flight, SpaceX engineers collect mountains of data that inform design modifications. These changes can range from minor tweaks to substantial redesigns of critical components. This approach has allowed SpaceX to achieve remarkable improvements in performance and reliability in record time. The Raptor engine's thrust has increased significantly since its first versions, while manufacturing complexity and costs have decreased. How do they iterate so quickly? SpaceX's integrated manufacturing system allows it to implement changes rapidly. When an improvement is identified, it can be incorporated into the production line almost immediately, without waiting for contract negotiations with external suppliers. Before an engine is cleared for flight, it undergoes a final series of inspections and acceptance tests. Every measurement must be within precise tolerances, and every component must function flawlessly. Only then is the engine transported to SpaceX's launch facilities. At the launch site, the engines are carefully integrated with the rocket's structure. For Starship, this means installing multiple Raptor engines in a complex arrangement designed to optimize thrust and control. The integration process itself is a marvel of precision engineering. The Raptor engine represents not just a technological achievement, but a fundamental shift in how we approach aerospace manufacturing. Thank you for watching another episode of Everyday Nuggets and joining me on this exploration of how SpaceX builds some of the most advanced rocket engines in history. If you enjoyed this episode, please like and subscribe for more videos. If you have suggestions for other everyday things you'd like to know about, please leave them in the comments below. Stay curious.